Hi everyone, I'd like to talk a little bit about the lattice of subgroups for the dihedral group of order 8. So I'm using the notation D8 here for the dihedral group of order 8. So I've got the group up here at the top of my diagram, and then underneath it, I've got subgroups. So for example, the subgroup generated by R, that's a subgroup of D8. And if I wanted to write out what those elements look like, I would just take and write the set of powers of R. So I have an R in there, that's my generator. I've got R times R, that's R squared. I've got R times R times R, that's R cubed. I've got R to the fourth, but that's just 1. And that's the only, those are the only elements I have in the subgroup generated by R. Now, if I look at the subgroup generated by R squared, well, I've got an R squared in there. I could do R squared times R squared, and that just gives me R to the fourth, which is 1. So that's why the subgroup generated by R squared sits below the subgroup generated by R. We've got a subset containment here. Notice that R squared, the subset of elements we get when we generate with R squared, that is a subset. It's a subgroup, in fact, of the subgroup generated by R. And I can see that relationship really nicely here when I write out all the elements. So I think it's really helpful to play around with the subgroups generated by, RS or RS and R squared. Literally find all the powers of those generators, multiply them together, see what you get, and you'll see the subgroup containments quite nicely if you start writing out all the elements. And I'll give you a hint here. All of the subgroups on this line of our lattice, all of these subgroups have order 4. So if you are only finding 2 elements in there, you have to keep working. So I'm giving you a hint. And then down on the line below here, all of these subgroups, all of these are of size 2. So all those subgroups have order 2. And then down here, this is order 1. Obviously, we just have the identity. And way up at the top here, we have the whole group, which is order 8. So we have this nice divisibility relationship. 1 divides 2, 2 divides 4, 4 divides 8, and so forth, criteria. And we'll see where that comes into play as we move through the course.